Hello everyone, today let's solve the problem number 647, palindromic substrings. So this is similar to the problem that we had solved previously, right? We had solved for the longest palindromic substrings. So today we'll be solving palindromic substrings. So what the question states here, we are given a string s, you can clearly see here, we are given a string s and we need to count how many substrings of s are palindromic. How many substring of S are palindromic means we have to consider every string that is present in the this one, right? S. In this case, every string, substring, or the string that is present in the every substring that is present in the S that we have to consider, right? So we need to count how many substring of S are palindromic, and a palindrome is a sequence that reads the same backward and forward. This we know, right? So a palindrome is just a sequence which is same when we read this backward as forward, backward and forward, or when we read the same backward as forward, you can call it anything. So in this case, S ABC they have given. Let's come to the example one here. They have given here, one second, S ABC. So we have to display all the palindromes and the number of palindromes that is present in the S, right? The number of palindromic substrings that we need to display as output. In this case, they have given 3. What is the explanation? Let's go with the explanation. 3 palindromic substrings here. One is A, one is B, and one is C. So always remember one thing: individual characters is a palindrome of itself. This is very important. So every time, this is one of the edge case you need to remember every single time when we are dealing with longest palindromic substring. This one palindromic substring, when we are dealing with the strings basically, right? So 3 palindromic substrings here we can consider 3 different characters, right? A, B, and C. So the output has to be 3 in this case. So output they have given here is 3. I hope this is clear. The second example here is same characters we are having A, and A. So we have 3 A's here. Output is 6. Why here output is 6, not 3? Because we are dealing with the same characters, right? Here the characters, all the characters were different, so the output was of 3. Output was 3 here. Here in this case, we have, sorry, just give me a second here. This one is, we have 3 A's here. So one is we are considering A. These are different A's, right? So A. This will be 3, and we are considering double A here, right? Double A. Next double A. Next here we'll come to the index 1 and index 2 here. This we will consider again. So this will be double A, and all the A's we will consider. That is also palindrome. When we read from the backwards, it is same as forward, right? So this one will also we have to consider. In this case, we have the output 6, right? So 1, 2, 3, 4, 5, and finally this one 6, right? So the count will be 6. So the output that we need to return in this case is 6. Here this is 3, this is 6. I hope the question is clear what we need to find, right? Initially, as usual, let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So let's discuss the approach step by step. I have considered the same example, first example that I have given in the question. So you can just follow the approach and you can just try the same thing for the example 2 as well, right? You'll understand this one clear, right? So S they have given here string A, B, C. Output here we got 3. Right, because A is different string here, B is different string, and C is different string. This will be 1, 2, and 3. Overall 3 we need to return here. So output we got here is 3. Let's see the approach here. So first thing is initialization part. We will be going with the DP array. Why we are going with the DP array here? Because we have to store the palindromic substring somewhere, right? So this will be Boolean DP array. Why this is Boolean DP array? Because if it is a palindromic substring, then we have to increment this one result. If it is not a palindromic substring, then what we will do? We will just keep the result as it is, right? So this is, we can consider this one as Boolean DP array or just DP array, just to store the palindromic substrings. Also here we are considering a result variable. Why we are considering result variable here? Just to count the total number of palindromic substrings. We have to count the total number of palindromic substrings that is stored in the this one DP array, right? So that is the reason we'll be considering the result variable. I hope this is clear. This is the initialization part. So step 1, let's come here. In this case, j is 0 initially, means we have to process a. So when I is 0, s of 0 is nothing but this one. This is s of 0, this is s of 1, and this one is s of 2 here in this case, right? So we are considering s of 0 here, nothing but we have only a. So this is palindrome, right? So this is palindrome a, because single character is always palindrome of itself. So this is a palindrome in this case. So I have said we are considering the boolean dp array. In this case, dp of 0 will be true. So we will increment the result from 0 to 1, right? Initially we have kept the 0 to 0. We have initialized we have initialized result variable, res variable, to 0 initially, right? So we will increment this one to 1 by we have got dp of 0 equals true here, right? Boolean dp array. So this will be 1. Let's move on with the step 2. So here step 2, when j equals 1. J equals 1 means we have to consider here two things, a and b. We are considering both. This one here, a and b, we will be considering when j equals 2 here. So let me come here. S of 0 we have a, and s of 1 we have b. So when we read this from backwards, so ab is not equal to ba, right? So just give me a second here. So this is not a palindrome, right? So let's come to this part. S of 1 equals this one, b we have. So we have considered here ab first, then we have to consider only b. We have already considered only a, we will be considering only b in this case. So this will be s of 1 equals b. Yes, this is a palindrome, because a single character is always a palindrome of itself, right? So this is a palindrome. I'll just give you, yes, this is a palindrome. So this one dp of 1 will be true in this case, and result we are incrementing from 1 to 2. This will be the second step. So let's move on with the third step. So I'll just come here. For the third step, we have to consider whole, this one, a b c, 3 letters we have to consider, right? So I'll just come here in this case. Let me come here, just give me a second. S of 0, this one here we will get ac, because s of 0 is a, s of 2 we are considering, we are processing c here. In the previous step we are processing b, and in the first step we were processing a here, right? So here in the step 3 we are processing c. ac equals to ca, no, right? So here this is not a palindrome in this case. So next we will go with s of 1 and s of 2. So bc equals cb, no, it is not a palindrome here. In this case, s of 2 equals c. So single character is always a palindrome of itself. So this is a palindrome in this case. So dp of 2 will be true in this case, because we have found one palindrome c, and result will be we are incrementing from 2 to 3, as the dp array is true here, right? So we are incrementing 3. So the final output that we got here is, that's what we have to return, result 3 here, right? So here, so the final count is 3 that we got, same as they have given in the output here for the example. This one abc 3, and the final count that we got here is 3 as well. So this approach works absolutely correct. This is the approach that we will be going with, right? So I hope the approach is completely clear. Let's discuss the edge cases one by one. The first edge case is for single character string. Input a we have considered, output will be 1. Why? Because only one character is present here, so only one palindrome, so we have to return 1 in this case. Let's move on with the second edge case. Nothing but all identical characters. All identical characters, we have output 10 here. So you can just check 1, 2, 3, 4. This will be 5, 6, 7, 8. This one 9. 3 A's also we have to consider, and finally 4 A's we have to consider, 10, right? So output will be 10 in this case. So many overlapping palindromes here found. So you can just check for this. Nothing but a. So a4 5 6 7. Just give me a second here. A will be one more time. This one will be 3 times, right? One double A. This one and this one. 8 here. Double A and this one 10, right? You can just count here. Output will be 10 in this case. So the third edge case will be here. No two consecutive characters are same. When I say no two consecutives are same, we should be having different strings here, right? So the output in this case will be 4 because only single characters are palindrome here. A, this is one palindrome. B is one palindrome. C is one palindrome, and D is one palindrome. So the first example in the approach that we saw, right, for ABC. So here the same thing, we have considered extra character here. So it will be 4. For this it will be 3 because all the characters are different here. Only single characters are palindrome here. In this case it will be 4. I hope this is clear. Next, let's go with the fourth edge case. Nothing but even and odd length palindromes. This is the final edge case. So when I say even and odd length palindromes, we are considering ABBA here, right? So the output will be 6 here in this case. Why the output will be 6? Because here we get this one. A is one palindrome. B, again B we have to consider because we have two B's, and A, one more A we will consider because here 2 times A, 2 times B. So ABBA is one thing, and BB is also palindrome, fifth one, and sixth one here is ABBA. This is also one palindrome. So these 6 we will be considering here in this case. So this is even and this is for the even and odd length palindromes. So these 4 edge cases that we need to keep in mind. So the first edge case that we went with here is single character string, and the second edge case that we went with here is all identical characters, and the third edge case that we went with here is no two consecutive characters are same, and the fourth edge case that we went with here is even and odd length palindromes. I hope all the edge cases are clear here. Next, what we will do, let's start writing the code. So let's start writing the code here. First, what we'll do, we'll be making use of the length of the input string most of the time. So I'll just consider here n equals length of the string. So this is one thing. We are just getting the length of the input string initially. So as we are discussed in the approach, we will be going with we have to create the DP array. Why? Because we have to track the palindromic substrings, right? So if you have seen the approach, you should be knowing that we have to we'll be making use of the DP array. So let's create the DP array fast. So I'll just give here DP equals new array of n, and let's fill this one with false here. This is fine. So let's initialize the count of palindromic substrings. So I'll just give here let result equals 0. So here initially what we have done here, we have initialized the count of palindromic substrings. So the next thing here is, we know this, we have to expand the right boundary of the substring and the left boundary of the substring. So here this will be for loop. So let j equals 0, j less than n, and let's increment the j. This is fine. For let I equals 0, I less than or equal to j, then finally let's increment the I as well. I hope this is clear. Let's check if the characters match and the substring is a palindrome or not. I can write the simple if condition here. S of I here, this is equal to S of j. Then what we will do, and also we have to go with this one, j minus I. If it is less than 2, let's go with one more thing here, dp of I plus 1. What we are doing here, why we have written a simple if condition here, because we have to check if the characters match, right? If the characters match, then only it is said to be palindromic substring, and we are storing that one in the DP array, right? So that's what we are doing here. We are checking if the characters match and the substring is whether palindrome or not, right? So I hope this is clear. The next step here is let's mark this substring as palindrome. So here this will be dp of I. This one, let's initialize this one to true here. Also, let's increment the result count. So result count, it will be result plus plus, right? Else what we will do here, this one dp of I, this one, let's initialize this one to false here. This is fine. This is not a palindrome, right? So if it is not a palindrome, then we have to initialize iterated value of the dp to false, right? This is nothing but we are incrementing the count if the palindrome is found. If the palindrome is not found, or if it is not a palindrome that is present in the dp array, then we have to initialize this one to the false, right? So I hope this is clear. So next step is final step. Here this one we have to return the result, means we have to return the final count of palindromic substrings. In this case we will return result, right? So I'll just mark this one, let me format the code once, and let me hit the run button. I hope this works. Let's see. So here you can clearly see the sample test cases are getting passed here, right? So let me hit the submit button very quickly. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case, right? So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming, or you can just call it as expand around the center as well. So overall time complexity here would be big O of n to the power of 2 or n square here in this case. And what would be the space complexity here? Overall space complexity would be big O of n here. Why the time complexity here is big O of n square and the space complexity here is big O of n? Time complexity here is big O of n square because we are iterating over the possible strings, possible substrings, nothing but big O of n square iterations, right? And we are checking for the palindromicity in the constant time. You can clearly see we are making use of the two for loops here. So we are just iterating over all the possible substrings, which is of big O of n square iterations, and also we are checking for palindromicity in constant time. This is fine, right? So this is one thing. And what would be the space complexity here? The space complexity would be big O of n as well. Why the space complexity here is big O of n? Because we are making use of the dp array of size n to store the palindromic statements. Again, I'm telling, we are making use of the dp array of size n to store the palindromic states, right? You can clearly see here dp array of size n we are making use of, right? Just to store the palindromic states here. So that is the reason space complexity would be big O of n. Here in this case, overall time complexity would be big O of n square, and overall space complexity would be big O of n. I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.